So, hello all of you. My name is Shiv Subramanian, and you're watching Troubleshoot Tech. And welcome you guys again into the another session of Docker. Right. So, in the previous video, we have talked about the basic networking inside the Docker containers. Right. So, today in this video, I'm going to tell you about the NAT. Right. The network address translation. This of two types, DNAT and SNAT. Right. So, and one more thing in the previous video we have left out, that was discussing about the driver, which is known as host, right? We have talked about the bridge, we have created our own network of the driver bridge, right? Right. So, please go and see through the video. This is an extension of that video, right? So, first we'll talk about the host driver, right? And then we'll slowly move to the natting and patting part, right? So how you can just uh, use your containers or access your containers from outside world, right? For maybe from my base that had Chrome, or maybe from my mobile phone, right? So we'll be discussing about a use case where we'll launch our we'll launch a web server, right? You know how to do that. I have show that you even we have also created the image of PHP web. So we're going to use the same image because this image has HTTPD software, right? By which we can create an Apache web server, right? It is inbuilt with a PHP software, right? We have created, and it has all those necessary things for and configuring the web server, right? So we're going to use this and do the rest of the things right now, right? So, let me start from this, right? Let me start from this. What this host driver means, right? So before this thing, right? Before this thing, I want to tell you something. So if you are using a virtual box same as me, right? So by default, your virtual box is not connected with your base system, right? So what you have to do, just press right control C, and you're going to see the screen something like this, and you want to put your this red hat into, or this virtual box into the bridge adapter network settings, right? How you can do that, you just have to go to devices, then network, and then network settings, right? As you can see, I am attached to the bridge adapter, right? Bridge adapter. So by this doing the bridge adapter, your Red Hat system will technically connect to the NIC, or the network interface card of your base Windows system, right? So by default, when you just launch your virtual box, this would be put at NAT, right? But don't put it at, put it in bridge adapter, right? So click OK, and then again, if you want your screen again, that just press right control C again, right? So yeah, so it is always a good practice to disconnect your network and again connect it, right? So disconnected. So let's just check that if I'm connected to the internet or not. So yeah, it is pinging, it is working fine, right? So now let's talk about the one of the important driver, right, which is the host driver, right? So as you can see, the host driver always tries to uh, access or get the system configuration of your NIC, right? So it is something like this, that if my this is my base system, right? So this is the IP address of my base system, right? So this is the all the IP addresses or network cards which are running in my system, right? So this is the actual NIC of my Red Hat system, right? You know this, right? You know this, right? So we'll talk about Docker Zero, what is Docker Zero, and all of kind of things. So these are the network cards which I am having. So the host driver, what it does, it copies this whole configuration, or this whole network interface configuration only, right? So it will access this whole thing, not any other configuration, just the network configuration in the host driver is, it is copied, right? Exactly like that. So without any delay, let's see what it does, right? So so let's see what images that we have. But obviously we're sure we'll be using the PHP web server in that, right? So for accessing your web server from maybe other systems or from your base Windows system or from a mobile phone, either what we can do, we can put that container in the host driver, right, and we can access it, right. So that is what I'm going to show you now, right. So what I'm going to do, I'm going to do docker run and container, right. Maybe let's say just put it in diminishing or detach mode, right. So it's always good practice to give a name, so let's give it as os1, right. And what I'm going to do, I'm going to launch the php web image that we have created, and uh, and in which network we have to put, right, the option which is hyphen hyphen network, and I want to put it in host, right. So as soon as I launch, it launches, right. You can see with the docker ps command. Okay, so it is up, right. It is up, it is working fine. And if so if you want to see, so what I'm going to show you now is like this. This command, right. This will give you the uh, bash shell of your container, right. So as you can see, it copies exactly like your system. Actually it is another system, right. It is another system. As you can see, there's a slight difference in my system. So it copies the whole network configuration from my base system, right. So the terminal also looks something like same, but it is not like that. How can you check, right. We can do one thing. So this is my base red hat system. So in my red hat system I don't have the software called httpd, right. How can I check this? Like, I can use rpm hyphen q, which is query command, to see that if I have http software installed or not in my base system. So you can see it is not installed in my base system. So right now I'm into my container, and if I run the same command as this, it says yes, it is installed. It is installed over my CentOS system, right. So we have created this web server on the CentOS system only. So as you can see, it is installed over that only. So it just copies your network whole configuration like this. So if you do if config command in this, inside this container, you can see the exact networking just like your base systems. That is the beauty of the host driver. It just copies the all the network properties or attributes from your base system. So right now I'm system, so I can actually so let's exit from this container. So I can so I've exited from the bash, right. So still the container is in the running state, right? So this, so because this is my this is put into the host mode, I can directly access it from my base system, right. So if I go to my base system chrome, right. So let it open. So I can access this from here, right. So I can use I think this is the ip of my base system, if I'm so right. So let's see, uh is, yeah, 192.168.43.30, yeah. So it is same, right. So if I press enter, you can see it will this um not working. Why? Just let me check. Maybe I have changed some security settings, so let me just do uh, let me just stop the firewall. It's not good practice to stop it, but maybe I have changed some system settings because I do a lot of things in the red hat. So just let me stop it, right. You don't have to stop it in your base system. You don't you have not changed, you have not changed any system settings, right. Maybe I have changed some, I will refer it later, right. So I have stopped the firewall right now, so it will not drop or do anything with my packet. Let's see if it works or not. So yeah, it is working fine, right. So maybe I have changed some system settings, maybe, so that's why the firewall is not allowing. I'll check that later, right. You don't have to stop it, it will work for sure, right. So as you can see right now, it is working great. Even if I refresh, you can see the bytes or the number of data packets they change, right? So they always ping to some other things, right? So yes, so it is working totally fine. So so it is not in the perfect manner. So let me quickly go inside the bash, right? So inside the container, and you know how to uh, change the change the alteration of the website that we have, right? So we have to go inside the where www html, right? Inside this we have the index.php page, and let's open it with the vi editor. And yes, so yeah, so it is not configured that much. So let's do that. Let's quickly do that. And you can see even I haven't just closed the PHP, right? So even it works like that, right? So that is the beauty of PHP. So WQ save. Yeah. So this is the thing. So let me exit from this container. So from the bash, right? Not from the container. So container is still running. So yeah, now if even I refresh that, so now it is working fine, right? This is the manner in which we want to see, right? So this is my IP, and this is how the host network works, right? This is how the host network performs, right? It copies your base system's IP address and use this as the hosting IP address for your container, right? So this is how the host network host driver works, right? More specifically, right? So so that is the thing, right? So what I'm going to do, I'm going to remove the OS one. I want my environment to be clean, right? So if I do docker ps hyphen a, my environment is totally clean, right? So we have talked about the host driver. This is the simplest example of how the host driver works, right? So now we just move on to the next topic, which is the NAT part, right? NAT part. So before this, let me show you or introduce you some terminologies like this, right? So this system we have already seen from the previous video, right? So what happens actually in this, right? The question arises that how does your container directly connects to the internet, right? How does this happen, right? You can access your container, you can access the internet inside your container. So how does that happen, right? So as you all know, this container internally, whenever created, it connects over to your base Red Hat's router or switch, right? It has some IP address, it switches, right? And from your routers or switches other end, it connects to the internet via the ISP, whatever had, maybe Airtel or Vodafone or Idea or Geo, whatever the IP address, whatever the ISP that you have, right? Where you get this, maybe from your mobile phone. Right now I'm using my mobile phone as my DHCP server, right? I'm using internet from my mobile phone, right? So it is working like that. So whatever the container that are there, they internally connect to a switch or router, which is the Docker switch, right? So internally they connect to this, and then they just move on having other IPs to the via the ISP and then to the internet, right? So that is one thing, right? For this, there are two types of network that we or we can say a network group that we normally have, right? Those two network groups are known as public, right, and another one known as sorry, private, right? So let me just keep it big. Right. So this is known as public and a private network, right? So whatever the containers running the inside the systems, or whatever we have, they are private networks, right? So if I go my to my base system, and if I write cmd right, if I see my IP address, right, with IP config command, right, whatever the IP address I see here, it is my private network, right? It is not my public network, because uh, the private network can't get access to the public network. It is not possible, right? Private cannot get to private, right? Private cannot to get public, and public cannot get to private networks, right? Right. Only public can ping or get access to public networks, right? Only it can so if I just clear this bit out, right, public can only get to public, only this is only possible, right? But if I say that this is a private network, right, so it is a, so sorry for my handwriting. So if I say that this is a private network, then how can I connect this to my internet, and how it is possible? It is all because of your switch or your router which is having, right? I always talked about this two ends, right? So what it does, it internally gathers your IP address, and there is an other end in which it has a public IP, right? It has a public IP which goes to the ISP and say, hey, I am in a public network and I want some access, or maybe from maybe a web page or some data. So this ISP will provide that data to the internet, and again it will come back to this IP, right? So but if the container's IP address goes via the router and to the ISP, the packet will be dropped, because it say you are not a public IP, you are a private IP, and I don't allow you to get to the internet, right? So that is the thing which is which normally happens, right? So where you can check it, you can just go to Chrome, and you can see what is my ipaddress.com, right? You can here you can search, you can see that it will tell you all the informations that you have, right? So this is my public IP, right? So this is this end, right? This is the IP address which I have. Let's say, what is this, 157.137.240 or something like this, right? So this end is the IP address. So this is the public address which does the shifting, right? Which does the shifting, that this IP address, when it pings to ISP, it say, okay, so you are a public IP, and then only I will allow you to access to the internet, right? So this concept of changing the network address, right? Your IP is something different. So in my Red Hat system, that you always see the IP address as 172.17.0.2, or maybe some other thing like that. So this is my private IP, right? So this is my private IP. So internally what happens, this IP is being replaced by this public IP, and then it goes to the ISP for getting the for fetching the data from the internet, right? So this concept is known as NAT, right? Which is known as network address translation, right? Which is known as network address translation. And this is of two types, right? You might know, right? Which is known as SNAT, and another one is DNAT, right? So this is what happens actually, right? So let's understand what is SNAT and what is DNAT, right? So I have made a kind of good looking diagram, right? Right, so let's understand that. So if let's start from here, right? So let's assume that your IP address of container one is 172.17 uh, uh, point oh point 2, right? Maybe like this. And this IP address may be 172.17 sorry, point oh point 3, right? Like this, right? So what happens internally? Let's assume that your container one with this private IP, it goes or it connects to this switch or of this container, right? So what happens, it internally, if I want something from internet, maybe let's say a web page, right? If I want a page from the internet, right? What I do, I go, I tell a request, or I send a request with my IP to this switch or router, and it internally, what it does, it creates an IP packet. This is known as an IP packet, right? And what this IP packet contains, it IP packet contains two things, right? It contains uh, sorry, just let me, yeah. So it contains two things, which is known as source address, and another one is a destination address. So what actually happens, this source address, what is your source address? This is my source address, this is my source IP, right? So this is number two, so two, right? So and the destination address is the address of my Google. So let's say, assume that it is 8 only, right? So what internally happens, this end will change this source this source address, and it will change to this to its public IP. So right now, let's assume that this public IP is nothing but, let's assume a number as 203. Let's just take the last digit, right? So 203. So it will what it will do, it will replace this source address with 203, right? Sorry for my handwriting, you have to bear it with me, I'm sorry for that, right? So what it does, it actually change this address with 203, right? And then this end will go to the ISP, and the ISP will check, so if this IP is public or not. If it is private, it is coming from private network, it will drop it. And if it is coming from a public network, it will allow it to access to the Google, right? So whatever the pages that we want, right? So it will happen, and then it will again generate, the Google will generate a response packet, right? From which is again having an IP packet of source address and a destination address. So it will put its source address, and it will put its destination address as 203 only, right? So this packet goes to ISP, and from ISP it will go to this router or switch, right, which you are having in your system, and it will again change this packet, and it will change its IP address to again your public IP, which is 2, sorry, which is private IP, which is 2, right? And then it will transfer the packet from the switch to the container, right? So by this method, right, because of this only, you can access the internet from your private networks container, right? So so what happens actually, because I'm changing the source address, right? I'm changing the source IP address to my public IP. This is known as SNAT, right? This is known as SNAT, right? Which is source network address translation, right? Just source network address translation, right? And the request, which, or the reply, which comes from the internet, right? It what this what this router does, it changes its destination IP to your container or your private IP. So this is known as DNAT or DNATing, which is destination network address translation, right? So these two concepts regularly happen always inside your container, right? So this network is nothing but your bridge network, right? We have uh, sorry, this bridge, right? We have talked about this, right? So internally this happens, right? So internally in Docker, the SNAT is always enabled, but a DNAT we have to enable it, right? So we have, that's why we are into the topping of netting, right? The network address translation. So we have just got a brief idea what is natting, right, and what is SNAT and what is DNAT, right? So this is how your internet works, right? So it is so simple to do the things, right? So let's get on to the practice right now, right? So yeah, yeah. So let me log into my Red Hat system, right? So yeah, so right now I'm having these images right now, right? And my environment is clean, right? So the users which normally use the things, right, or which normally use other than the Red Hat version 8 systems, right? For them the netting will be quite simple, but for those who are using Red Hat version 8, they have to change some things, right? It is not easy, sorry, it is very easy to do the things, right? I'll just tell you how, but just before I'm remembering of one thing, I have to tell you something, right? So right, so this is another image which I wanted to share with you, right, what we are going to do now, right? So what we are going to do now, so this is a container. You know how this works. This connects to my internal switch or a router. This connects to the ISP, and this connects to the internet, right? So and again a response is generated, and this again goes to my system's router, and it gives the response to my container. So at this point, S natting is done, and also with DNATing, right, is done. Right? So yes, so it happens over the switch or the router. So what we have to do, what we can do, right? What I want to tell, that if from the outside world, even my Windows system, right? Let's make a diagram, right? Something like this, right? Yeah, this is my Windows system. Let's say, so even my Windows system, according to my container, right, according to my container, is something like a foreign or another private network, right? So this is again like a private network to this container. It says I don't know this container. According to Windows, this container one is a private network, and I have told you that I cannot access the or ping this container from the outside world, right? I can ping to my Red Hat system, like, so if this is my Red Hat uh, if this is my Red Hat system, I can ping it to this, but I cannot ping to this container, because according to Windows, the container one is an private network, and I can get onto it, right? So a simple explanation I can just show it to you, right? So let me quickly launch a container, just name as C1, right? Let's use just we have to gather the IP, so I use IPOS, which has just the IP address, right? uh, so let's just quickly run it, right? So let's use the ifconfig command, and this is my network IP address, right? So if I go to my base system, right? If I go to my base system, and uh, in the command client, right? Let me, okay, yeah. So if I try to ping the container, right, which is running inside my Red Hat system, right, I cannot do it. It will not ping, right? Obviously, it will fail in some timer, right? You can see this request timer. So I cannot, because according to my Windows, right? According to my Windows, this container which is running inside my Red Hat is a private network, right? I cannot ping it to it, and vice versa. I cannot ping from container 1 to Windows, right? It is not possible. But because my network card of my Red Hat is connected to my Windows, I can able to ping to Red Hat, right? So if I go to my base Red Hat system and ask that what is your IP address, let's quickly see. Right, so this is my IP address. So if I try to ping my Red Hat system, which is 192.168.43.13, you can see it is pingable, right? Because my network card of Red Hat is actually attached to my network card of Windows, right? I have shown it to you with the bridge adapter, right? So what we can do to access the containers, we have to do something called DNATing. So we have to enable DNATing. As I already told you, in Docker by default SNATing is enabled, but DNATing is not. So what we can do, we have to tell the Red Hat system that if somebody comes to you, right, with your IP, right, with your IP, which is something like 43.13, right, comes to you, you forward this request to my container, right? You forward this request, like I have told you about the I have told you about the source address and destination address, right? So just you what you just change the destination address and put my address in that destination block and transfer that request to me, right? So that is what we have to do. But this is we can do this easily, but there's some disadvantages in that. What is that? So if maybe I run multiple containers, right? So maybe this container may be running like websites or web pages, and this container running databases. So if I want to access container 2, I have to change the rule of forwarding, right? I have to change the rule that so if I want to access container 2, I have to again change the rule of forwarding, that this time please forward this to my container 2, right? So and again, if I want to access container 1, I have to again change the rule of forwarding, right? So this is probably known as IP forwarding, right? This is known as IP forward, right? uh, it is better, I think, to just write it, right? So it is known as IP forwarding. Sorry, right? So it is known as IP forwarding. So I have to forward the IP address to them. So instead of what I can do, I can just do the same thing, that if somebody comes to you with your IP address, but with some port number, right? I mean, you have seen that your IP address has some port number always, right? So by default the web server port number always works on 80, right? Always works on 80 port. So if somebody comes to you or comes to your IP to the Red Hat system with the port number 80, you forward that request to this container. Or if somebody comes to you with the IP address as 24, you just ping this container, or connect to this container which is running on a database server or a mail server, normally mail server, which comes from 21 or 24 port number, right? So this thing, what we are changing, we are not changing the destination address, but we are changing the port number. So it is known as patting. It is known as pat, or port address translation, right? It is known as pat. So this is what we are going to do. We are going to because we have to because we may run more than one containers in that. So what we can do, we can just create the patting things, right? So the Red Hat's IP address is same, will be same, only the port number we can change, right? So this is the thing by which we can do this. So before that, you must see that so let me exit from this container. So what you have to see that if in your Red Hat system IP forwarding is enabled or not, right? So how you can just see, you have to just write system ctl, right, hyphen a to get all those lists, and just do one thing, just get me the IP forward. Okay, so there's some typo error. Okay. What happened? It's not working. Okay, so some something known as IP forward must be here. So let me check. Okay, so there's too much. Why is it not working? Okay, so maybe like, oh, so my firewall was stopped, right? So let me start, right? System ctl start firewall, right? So if I now do this, it's still not working. mm, what is not working? Okay, so it was a typo error. It was underscore, right? Sorry, maybe I have just forgot it, right? So as you can see, by default, the IP forward is set to 1, right? So it should be set to 1, right? So if it is 1, though this will forward the package to, or and it will enable the forwarding of the things, right? So just always remember that it is IP underscore forward, right? So maybe I have forgot a little bit. Sorry for that. I'm duly sorry. Right. So let me remove the container. Just let me clean my. I think it was C1. Yeah. So let me start from the very zero, or from the fresh, right? So what we're going to do now is we're going to use this padding to do the things, right? So anybody who is using other than Red Hat 8, what they have to do, they have to just use docker run it, or maybe just in de detachable mode, right? with the name um, with the name as C1, maybe, right? With the name as C1, and and for padding they have to use a option called hyphen p. In this, the p is in small case, right? And now I have to define which port number that I have to give, right? So by default, the HTTP server always works on port number 80, which is in my base system, right? So whichever comes from my base system 80, I have to forward it to maybe another let's say another IP address, or another IP address, right? So let's say, or like let's say so let it be 80 only, right? We can do other things afterwards, right? So I'm using the PHP web server with version 1, let's say, right? So let's use version 1 of this. So as soon as you run it, right, as soon as you run it, it will work for you, right? Who are working on other than Red Hat version 8, right? So in but in version 8, right, they have changed some security settings, or they have changed some policies with that, right? This will actually run in the Red Hat system, but they can't see the things, right? For this they have to do something which is known as changing the rule in the IP tables, right? So you can directly see some rules in the IP tables. For this you have to just write IP uh, tables, right, hyphen NV and capital A, right? So as you can see, okay, so this has some predefined rules, all that. What you do, they have some rules. You can just use capital F to flush all of them, right? So I have used this command for flushing, right? So just remove all the rules which they are having right now, right? So if I see there is no rule, or there is no created rule right now, right? So as you can see, there is something, there is a rule called chain forward, right? So this is the thing which it should be enabled, or which is set to be accept, right? So if in your system this policy is not changed to accept, then you just cannot or the IP forwarding is will be not enabled, it will be dropped, right? So by default, if you have don't have this accept, or it says drop, so you can just change it. Right now in my case it is accept, so if in your case it is a drop, you what you can do, you can just use a option called hyphen capital P, which is say policy. I have to change the policy, and what I have to change, I have to change forward to I have to change the forward uh, rule, right? The forward policy to accept, right? So this is what I have to do. You can just use it, and it says enter, and you can just check again. So it will show if in case it was set to drop, right? So this is the thing that you have to do, right? So it is so simple. You just have to put up another thing, right? Another thing. So when you do this, right, when you do this right now, a container is running with the C1, and you can see that it is whichever IP is 0, right, whichever IP comes from the 80 port, the same 80 is transferred to my container C1, right? You can just use the to see the network which is running, right? So you can see net stat with the option called DNLP, which tell you all the okay, this was some typo, right? That, right? Huh. So yeah, so now you can see that something from the 80 port is listening, and what it does, it internally goes to Docker proxy, right? So this is another beautiful term, right? So this Docker proxy is nothing but uh, this end, right? Let me, yeah. So this end which does the part, right? So this is acting as a Docker proxy, right? So this is acting as a switch to enable maybe DNATing, or maybe patting, which you are currently which you want to do, right? Which you currently want to do. So right now I want to do patting, so this Docker proxy will do the patting for me, right? So that's why it is known as a Docker proxy, right? So now everything is done. So for just checking, let me uh, attach the container to see. Right. So uh, so I have changed some my security settings, so probably the patting won't work in my system, right? In my system, maybe if I write 80, yeah, I know it won't work. So I have changed some security settings. You don't have to worry about. You don't have to do that. So what I'm doing, I'm just disabling my firewall, for just showing you the practical, right? systemctl stop firewalling, right? So it is stopped, right? So now if I go to my system and just refresh it, you can see it is working great, right? And it says that this is my IP address, right? So it is not in the well-defined form again. So just let me quickly go www html, right? And just change to vi editor and index.php. So you know the things, right, how to do this, right? So let me quickly do the things. Right. So now if I again go to refresh my page, and you can see your IP address, right? You can just how simply you can just do the things, right? Or whatever the thing that you want to do, you can do this, right? So right now what I have done, I have used the same um, 80 port, right? 80 port to listen, or you can just do whatever you want, maybe um, 80 comma 4 1 2 3 4, whatever. But there's something that you should remember about, which is which is that, let me see, right? So after writing the option called hyphen p, we always write something like this, right? So so the first 80, which is the which is my base system's port number, right? So since I'm using the http services, so my first thing is always my base system red hat. So it will be 80 for web server, 24 for my maybe from my other mail servers or anything like that. And this number, which is you can give to this, right? Maybe like 1234 or 1334, whatever it may be like. So this will work like that, right? So whatever the IP address you provide, it will work for you. Right? So as you can see now, my system is working great. And not even from this, you can even use your mobile phone, because since my mobile phone is connected to my base system, I can use this system to this. So if I write in my phone, on my phone's browser, http colon double forward slash 192.168.4013, right? As you can see, I can see my beautiful web service from it. So how can I show you? Yeah, maybe from my camera I can show you like that, right? So maybe you will see in mirrored form. I'm sorry for that, right? So you can see it is working great, right? It is working great. So let me do some changes, right? Quickly let me do some changes so that you can also see uh, the changes quite a bit, right? So let me like to print, sorry, okay, to print um, let's say, okay, some numbers or some text or whatever, just for uh, showing you the example, right? So if I go to my base system and just refresh it, you can see some digits come up, right? And from my camera, this is the thing. So if I just do a quick reload, right, you can see the some of the text with numbers, they came up, right? So it is working so much fine. So it is working so much good. It is working pretty good, right? This is the patting thing which we are considering right now, right? So this is the simple use case of how you can use the padding, or whatever you can do. We have just created our own network, right? So we can just use docker run, and with the diminishing mode, right? In the diminishing mode, and you can use your own network in it, right? So you can use your own network which we have created, right? We have created a network called a net1, right? We have created this, right? And it's always good practice to give a name. So let's give us C2. And what we want, we want a PHP web server with version 1, and we have to enable patting, right? So this is option called -p. Please note this is small p, right? So I want just, let's say 1234 will be my port number for forwarding, right? So just a simple click and it will, okay. So we'll program external connectivity. Okay, so port is already allocated. Okay, so I can't use this port, but I think it has created the uh, uh, container. Okay, so just let me remove the container C2. Okay, so again, uh, just choose another port number. Let's say 1553. Let's say it could be anything, right? Okay, it is, so this port is also already allocated. Okay, let's just wait. So maybe I have used all this port number right now, right? Okay, so you got the concept, right? I don't know which port number I have left with me free, right? So you got my point. You got my thing, that how you can use the um, port system with this, right? So yeah, this is how you can use simply the patting, right? So this is the thing. So let me do one thing. Let me quick quickly, maybe I have changed the port number, maybe just right. So let me do one thing. So if any system come to this port number 12345, just give it to me 80, right? So to remove the rename the container cannot. Okay, so container already created. Let's say C3. So okay, pair programming. No change or match that name. Okay, yeah, okay. So yeah, so because I have stopped the firewall, right? So when you stop the firewall, the IP table rule, it goes off, right? So no chain target match them. So what you have to do, you have to again start the firewall systemctl start firewall D, right? You have to start. So you don't have to do this thing because I have changed some security settings in my system. You don't have to do this in your system. Yeah, right. So let's say C4, right? And again run, and it will run. So it has run perfectly, right? So I have to stop my firewall again for showing you this practical. So you don't have to do this. You don't have to do this, right? So it is done. So if something or some IP comes to this IP address, right, it will to my base system, it will direct my thing to the 80 port number of my container, right? So C4. So let's try this. Let's try this, right? So my base system IP is same. You know this, right? So I have to just change the IP address colon 12345, and you see it's working fine. It is totally working fine. And you see, this was the IP address of our network. If you remember from the previous videos that I have made, right? So this was the same IP address of it. So either you can check it, because I'm not inside my container. You can just check it. Let's see, 4, I think, right? I can use ifconfig command. I can see this is my IP address, and my patting is working very good, right? So the basic thing which you want to just always remember, that after using -p, the the thing which you want your port number to come, you have to write like that. Maybe 80, you can use the same, or you can just do write 1 2 3 4 5, and this 80, this is the thing which you should remember. I'm telling again and again, this thing, it is the thing which you have to remember again and again, because this you have to see. So if you're using web server, you can use port number 80, or if you're using any mail server, you have to use 24, or if you're using any other server, maybe your API server, you have to get a respective that port number only, so then only it will work. So please, please, please remember this thing, right? So only then only this thing will work. And again, I'm telling you, I have changed some security settings maybe, so that's why I have to stop my firewall, but you don't have to stop your firewall, right? So if your firewall is stopped, please start it, then only you can do the patching things, right? So this was a simple example that I was talking about natting and petting and all those things, right? So that's all it for today, right? It was a great lecture, I think, right? You must have learned most of the things about netting and the networking part, which I've told you. So in the next Docker video, we are going to tell you about the volume, the storage part of Docker containers, right? So if your Docker container crashes or shuts down, or something happens, or some error happens, your data won't be lost, right? You how you can retrieve that data, or you can store that data inside a volume. So that is all we are going to do for the next video. So until then, it's bye from me, right? Thank you so much.